Hello everyone, welcome to Lab BC Lab 5F. Today's topic is PNP BJT output characteristics for common collector configuration. So everyone has to set the following circuit schematic in LT-SPICE. So this is my BJT output characteristics in common collector configuration using PNP BJT. So we need to select PNP BJT transistor from the component library in LT-SPICE. Then we need to select two voltage sources, VBB and VEE, and need to also collect two resistors RB and RC of 100 kilo ohm respectively. So here my input sides consist of VBB and RB, that is base and collector, and my output side is emitter and collector, that is RE of 1 kilo ohm and VEE supply voltage, DC supply voltage. Note that it is a PNP transistor and here the emitter terminal is up. So you all might have to mirror image this PNP transistor. So for mirror imaging in LT-SPICE, you need to do control E. For rotating a transistor, you do control R, and for mirror imaging in control E. So with that, you will get this. So see to it that the circuit schematic should exactly look this way. And next, after placing all the components, right click on the VBB source, click on advance, none will be selected, then click on OK. Similarly, right click on the VEE source, click on advance, none will be selected, again click on OK. So this step will ensure that both VBB and VEE can be varied. Now to define our own PNP parameter, that is beta equal to 100, right click on the PNP, rename it as PNP1, and from the rightmost corner of LT-SPICE, we need to locate .op. We need to click on it and select the SPICE directive and type the following line, that is dot model PNP1 PNP BF equal to 100. So what does this PNP1 means? PNP1 is the name defined by the user, and PNP is a reserve keyword indicating that it's a PNP BJT, and BF equal to 100 means its beta value is 100. When you click on OK, after writing this line, this dot model PNP1 PNP BF equal to 100 statement will appear on the schematic. So this way we have defined our own transistor of beta equal to 100. Next option is we need to select the transistor from the components. Right click on the transistor symbol. So right click on this transistor symbol. Click on pick new transistor. So you can click on pick new transistor, scroll down and select BC557B. So again I repeat, right click on the transistor symbol, click on pick new transistor, scroll down and select BC557B and click on OK. So this BC557B number will appear onto the near the transistor. So BC557B is a commercially available practical BJT, NPN BJT. Next thing is for labeling the various input various terminals of this PNP transistor. So base, emitter and collector. So let's do that. So to label the base, collector and emitter terminals of a PNP BJT as base, collector as capital B, C and E, to add a label, right click on the wire, click on label net and enter a label. So either B, capital B, C or E. So you might have to do this 3 times and click on OK. So once you click on OK, the following label will appear as it is on your schematic. So in your LT-SPICE schematic, it will look this way: capital B, capital C and capital E. Okay. So next is, once your circuit schematic is ready, go to simulate, click on run. Next select DC sweep, enter the name of first source to sweep as VEE. The type of the sweep will be linear. Start value will be 0. Stop value will be 10. Increment will be 0.1. Now enter the name of the second source to sweep as VBB. Type of sweep will be linear. Start value will be 0.5. Stop value will be 2 and increment will be 0.5. And this means that we are varying the value of VEE voltage source from 0 to 10 in the steps of 0.1, and we are varying the value of VBB from 0.5 to 2 volts in the step of 0.5. Now click on OK. So this line dot DC VEE 010.1 VBB 0 to 0.1 statement will appear on the schematic. Also at the same time, a new blank window with x-axis from 0 to 10 volts will appear. Now we need to right click on that blank window and waveform window, click on add trace and select IE, the emitter current flowing through the transistor Q1. So select IE of Q1. Now, basically, emitter current in LT spice is generally in the opposite direction. So what we need to do is, after clicking on OK, you will observe a graph of IE versus VCC. So what you need to do is, you need to right click on this IE of Q1 and add a minus sign before it. Okay, this is just to counter the effect of this LT spice limitation of giving the opposite direction. So please refer that. Now, after adding the minus sign before this IE of Q1, so you will observe a graph of IE versus VCC, which is looking exactly as you are seeing on the screen. So VCC, but it is a graph of IE versus VCC. But we wish to plot the graph of IE versus VCE. Okay, the output characteristics. So in order to do that, right click on the x-axis of the plot. Now the quantity to be plotted will be VCC. So you change it and write it as minus of capital V bracket capital E. Now, why we do that? Because the collector current is grounded. So your VCE will be VC minus VE. The collector terminal is grounded, so VC will be 0. Hence, your VCE will be minus of VE. That's why we write here minus of VE. After doing that, click on OK. So your desired plot of IE versus VCE will appear onto your schematic, which will look exactly as follows. So IE will be in milliamperes and VC will be negative. So both will be negative, both will be in the third quadrant. These four curves corresponds to these four values of VBB, which will in turn corresponds to the four values of constant value of IB. So over here we have VBB going from 0.5, minus 1, minus 1.5 and minus 2. So this is my plot. Now you can select any one curve, and for different values of the don't refer this for different values of IE, you note down the for different values of VCE, you note down the values of IE. So here it is basically written wrong. Here it should be IE for different values of VCE. So basically here if you write VEC, all the values will be positive. Okay, so please take a note of it. So for various values of VEC, you note down the values of IE and that graph will be recorded. So this is how you plot the output characteristics for common collector configuration using PNP transistor. So you can take any one of the graph and note down these readings. Okay, so that's it. I think we have completed our objective today of plotting the output characteristics of for common collector configuration using PNP BJT. That's it for today. Thank you for joining.